Lesson 7, Counting Principles and Probability. In studying probability, it is necessary to understand the jargons used in this topic. By understanding the terms used, you can visualize what is happening and use correct strategy to find the solution to the problems.
Random experiment
is an activity that yields one and only one of the several possible outcomes.
Outcome is the result of a single triangle of a random experiment. Event is a collection of one or more outcomes of an experiment. Sample space is the outcome of a random experiment.
The two events are mutually exclusive or disjoint. Events, if they cannot occur at the same time. Below is the illustration of mutually exclusive events. Equally likely events occur if all the outcomes have the same chance to occur. For example, in tossing a coin, getting head or tail are equally likely events. Let's talk about probability. Probability is defined as the numerical measure of the likelihood of an uncertain event to occur. Let us proceed to the three conceptual approaches to probability. First is classical approach. In classical approach, the probabilities of all outcomes in the sample space are equally likely. The second one is empirical approach. In this approach, the probability of an event is based on the frequency distribution as a result of the experiment conducted infinitely many times. The last one is subjective approach. In subjective approach, the assessment of the probability of an event to occur is based on the degree of personal beliefs, experiences, and judgment. So these are the fundamental rules in probability. We are now in basic counting principle. Permutation. Permutation is an arrangement of a group of things in a definite order. In this rule of counting, arrangement of order of things is very important. These rules help us arrange a distinct object, taking R of them at a time. To calculate permutations, we use the equation NPR, where N is the total number of choices and R is the amount of items being selected. To solve this equation, use the equation below.
Permutation of n objects, some are alike. We have considered so far the permutation of n distinct objects. However, there are times that the objects that we are dealing with are alike or identical. In this case, the number of permutations are reduced depending on the number of identical elements. To solve this problem, we will have a new formula. As you can see on the screen, this is the formula that we are going to use. And we have circular permutation. Arranging different objects in a circular formation or manner is called circular permutation. Figure A and figure B on the screen cannot be considered as different permutation if dots are just moved in clockwise direction.
Combination.
It also deals with the arrangements of orders with no particular order. In combination, letters A, B, C, BAC, B, C, A, CAB, and CBA is the formula for combination is gives as.
We have the rules of probability. There are certain rules in probability that we must remember in dealing with probability problems. As you can see in the screen, these are the following two rules. We provided two examples where we can apply those two rules. We have example 7.6 where we can apply the rule number 1 and example 7.7 where we can apply the rule number 2.
Remember that when two coins are tossed, there are four possible outcomes. These are the HD, TH, HH, and TD. Therefore, Example 7.9. A BS accountancy student estimates that the probability of passing statistics subject is 0.6. The probability that he will pass the basic accounting subject is 0.5. The likelihood that he will pass both subjects is 0.4. Determine the probability that he will pass statistics subjects given that he passes basic accounting subject. Solution. Let E sub 1 is equal to the passing statistics and the E sub 2 is equal to the passing basic accounting. Thus, the solution is shown. Example 7.10. A recent survey asked 100 Anti-Kenyans if they are willing to be vaccinated with COVID-19 vaccine. The result of the survey is shown below. Find these probabilities. A. The respondent answered yes, given that the respondent was a female. Letter B. The respondent was a male, given that the respondent answered no. Solution. A. Let the E sub 1 is equal to the respondent answered yes if the E sub 2 is equal to the respondent was a male. Thus, the solution was shown. Letter B. Let E sub 1 the respondent was a male and the E sub 2 is equal to the respondent who answered no. Thus, the solution is shown. The Bayes theorem. The Bayes theorem was developed and named for Thomas Bayes in 1702 to 1761. Bayes' rule enables us to make new and different applications using conditional probabilities. We use Bayes' rule to revise probabilities, considering further information. This Bayes theorem is an extension of the conditional probability concept and is determined by the formula. The formula is shown below. Example 7.11. A factory has two machines, A and B. Machine A produces 65% of items and machine B produces 35% of the items in total output. Further, 2% of the items produced by machine A are defective, whereas 4% produced by machine B are defective. What is the probability that it is defective given that it is produced by machine A? Solution. Let the P A sub 1 is equal to the probability of machine A, probability of being defective and produced by machine A, probability of machine B, and probability of being defective and produced by machine B. The equation is shown. Example 7.12. Two identical urns contain 6 black and 4 red balls. 2 black and 2 red balls. An urn is chosen randomly and the ball is drawn from it. Find the probability that the ball is black given that it is from the first urn. Solution.